Welcome back, guys, to lesson 2.5 about linear functions. So I know that you've dealt with linear functions in middle school, and today we're just going to talk a little bit more about them. Remember, one of my goals in this class is to kind of challenge your way of thinking and make sure that you develop more of an understanding than just to do what I do, follow what I do, monkey see, monkey do kind of mentality. So without further ado, let's get cooking. So first, before we get into linear functions, let's talk about the average rate of change of a function. The average rate of change is found by dividing the change in the output values over an interval by the change in the input values over the same interval. So basically what that means, if I want to find the average rate of change of this function, I'm going to find f of -1. I'm not going to use that green anymore. I used it last time and it wasn't the easiest thing to see. So I've got to find f of -1. -1 will be 2 times -1 squared minus 3 times -1 plus 4. That's a plus 4, which is equal to, this one says 2 plus 3, which is 5, plus 4 is 9. So f of -1 is 9. Then I also want to find f of 3. So f of 3 would be 2 times 3 squared minus 3 times 3 plus 4. 3 squared is 9 times 2 is 18 minus 9 is 9 plus 4 is 13. So basically what I've done here is I found two different points on this graph at the beginning and the end of this interval. I know that the point -1, 9 is on the graph, and I also know that the point 3, 13 is on the graph. So to find the slope, or sorry, not the slope, to find the average rate of change of this function, I will do the change in the output. So that is 13 minus 9 divided by the change in the input, which is 3 minus -1. So this is 4 divided by 4, which equals 1. So for this function, over this interval -1 to 3, the average rate of change of the function is 1. So average rate of change is going to relate to slope. So basically, the reason we did this is if we can find the average rate of change of a function over any interval, for linear functions specifically, that average rate of change is the rate of change at every single point on the graph. So a linear function is just any function with a constant rate of change. The rate of change doesn't change for the entire function. So it creates a line. So does this table show a linear relationship? If it does, state the slope. So if you want to, take a second to pause this video, take a look at this table, tell me if it looks like a linear relationship, because I'm about to go on and go ahead and answer this question. So if you want to pause, pause now. So now that you're back from your paused video, hopefully, I want to look at basically the difference between the input and the output values here. So right here, as the input increases by 1, the output increases by 2. So what I'm looking for here is basically I'm looking for a constant rate of change, which means every time the input increases by 1, the output should increase by 2. So that happens here. Input increases by 1, output increases by 2. Here, the input increased by 2, which means the output should increase by 4, which is exactly what happened. And then here, input increased by 1, output increased by 2. Now here, my input increased by 8. So instead of increasing by 1, it increased by 8. Then right here, the output should increase by 16. So that is still a linear relationship because it's still keeping that 2-to-1 ratio of output to input. And the same thing happens here. Input decreases by 18, then the output would decrease by 36. So this is a linear relationship. Even though these x coordinates don't necessarily all have the same change between them, the rate of change between the output and the input remains constant. And the output to input ratio is 2-to-1, which is 2. So the slope of this function would be 2. So these are a few different forms of linear equations that we can write. So slope-intercept form is probably the one that you've seen hundreds of times. It's that's y equals mx plus b, where m is slope and b is the y-intercept. That's fine. We're also going to take that and we're going to define what slope and y-intercept mean in the context of a problem. Two more forms, and really this is the important one. When you get into higher level math, this is going to be the form that you use, point slope form. And that is y minus y1 equals m times x minus x1. The benefit of point slope form is that in order to find it, all you need is a point and a slope. You can do that with slope-intercept form too, but there's some algebra involved. For point-slope form, literally all you need is just a slope and a point. So we're going to show what that looks like in just a second. And then Taylor form is just another form of linear equations. You might see this one, it's just point-slope form. You just add y1 to both sides of the equation using the addition property of equality to get Taylor form from point-slope form. But really, these two are the two that you really need to focus on. So before we move on to actually writing an equation, we want to make sure that we understand what slope and y-intercept actually mean. So the interpretation of slope, what it means is that each time the input value increases by 1, the output is going to increase by whatever the slope is. Or this could be decreases, that could be increases or decrease if the slope is negative. So if the slope is negative, this would be decreasing instead of increasing. And then the interpretation of the y-intercept, if the input value of the function is 0, then the output of the function would be whatever the y-intercept is. So this is the interpretation of the slope and the y-intercept in context. And also I want to back up this real quick for just 1 second. This does not change. This interpretation of slope, every time the input increases by 1, the output either increases or decreases based on whether the slope is positive or negative. I want to make sure I make a point of that before I move on to the next page. So make sure you get down these interpretations. I'm going to move to the next page and we're going to practice writing an equation. So here's that data that we had a minute ago. So I want to write an equation for this in slope-intercept form. So I already know, because I did this a minute ago, the slope is equal to 2. So I want to write this equation in slope-intercept form. One of the problems that I have here is I don't have when x is equal to 0. Because remember, the y-intercept happens when x is equal to 0. So I don't have the y-intercept in this data. So what I'm going to have to do is I know that generally my equation is going to look like y equals 2 times x plus b, whatever b happens to be. But I need to actually find b before this equation is actually established. So what I want to do is I just want to pick a point, any of these points. I should end up with the same thing. And I want to plug in the f of x, which is the y value. So let's just take 9, 14. Let's say that we take this point. And I've got the 14, which is the y value, equals 2 times 9 plus b. So now I want to solve this algebraically. 2 times 9 is 18. Subtract from both sides of the equation. B equals -4. So then in slope-intercept form, this would look like y equals 2x minus 4. So point-slope form. We already know the slope. Point-slope form. Let's pick a point. Let's pick a different point this time, just for fun. Let's take this point right here, 7, 10. So here's my x-coordinate. Here's my y-coordinate, because f of x is the output of the function, so that's my y-coordinate. So this is going to be y minus y-coordinate, which is 10, equals slope, which is 2 times parentheses x minus x-coordinate, which is 7. And there you go. There's your equation in point-slope form. Nothing else left to do. That's my equation in point-slope form. Oh, God bless me. And just in case, if you want to verify that these two equations are the same, we'll do that over here. If I take this equation in point-slope form, y minus 10 equals 2 x minus 7, I can distribute the 2. Y minus 10 equals 2x minus 14. If you notice, if I add 10 to both sides of the equation, y equals 2x minus 4. I end up getting the exact same thing. So even though these two equations look different, they are still exactly the same thing as each other. So that is it for today's lesson. Today we talked about the average rate of change, the definition of a linear function, and then how to write equations of linear functions. So I hope that you took some good notes. I hope that you come to class ready to ask some questions, and I hope to see you again soon. Until next time, see you guys.